surface areas and volumes.
Okay. So in the last lesson, we have started new chapter number 13, surface areas and volumes. We revised the formula of surface areas and volumes of 3D figures we have already studied before. In 6th standard itself, you have started learning about the 3D shapes, their names and something. And in 9th standard, you have studied how to find their volumes and also the surface areas. So the formulas we discussed for cuboid, cube, cone, sphere, and two more shapes. Okay, and in the last lesson also we discussed how to find the surface areas of combined figures. If we combine two 3D figures, how to find the surface area. Some example questions we discussed, and today also we continue from there. We will discuss two more questions from the exercise of combination of 3D figures, their surface areas. Then we will move to next subtopic, that is volume of such shapes. That means the combined figures. Okay, shall share my screen. Okay, I will take a question here. Exercise number 7. We will discuss here. Okay, question is like this: a tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of Rs 500 per meter square. Note that the base of the tent will not be covered with canvas, that we all know. Okay, so the question I think is clear. A tent made with a cylinder and its top is surmounted by a conical top. A conical means a cone. Okay, so we want to find the surface area excluding the base, so that we want to put some canvas on top of this tent. We want to cover the tent by some canvas, and we want to find the rate of canvas at rate of 500 per meter square. So first we want to find the surface area and then multiply the answer we got by this 500, we will get the total cost. So first of all, we want to draw the picture. So how will the picture look like? Okay, so how will come? First we start with a cylinder. It's told that a cylinder, and okay, shall draw here. I think some flat cylinder, because the height is 2.1 only and the diameter is 4. So that means this will be a little bit flat cylinder. Okay, almost like this. Okay, and the top is some a conical top. A conical top, and its slant height and all are given, and its slant height is only 2.8. So as almost like this. Okay, a tent like this, a cylindrical tent with the top is surmounted by a cone. In case of tent, we don't have to consider the base. In the case of canvas, when we put some canvas, okay, so no need that. Okay, so look here. So the given measurements we can mark in the picture. So what all measurements are given? The height and the diameter of the cylinder is given. The height is given that 2.1 meter, so that we can write here 2.1 meter, and the diameter of the cylinder is given 4 meter. Diameter is given 4, so I think better we can mark radius. That's we need in the formula. So radius I mark here, or I think we can write the measure. So 4 is half. 4 is diameter, so radius will be 2 meter. And the height of the cone. Height of the cone I think this is not needed for finding the curved surface area, but in the case of volume we need. But actually here I think no need to draw the height. Then one more thing is given, the slant height of the cone is given. Okay, that is given 2.8 meter. So picture is like this: a cylindrical tent with top in the shape of a cone. Given that height of the cylinder is 2.1, diameter of the cone is 2 meter. So 4 meter, diameter is 4. So the radius will be 2 meter, and the this slant height of the cone is 2.8 meter. And it is asked to find the area of the canvas used for making the tent. Okay, so we want to find the surface area excluding the base area of the cylinder. So how we can write the relation or the statement sentence? Which all areas we want to add or subtract? So area of the canvas we can write like this: area of canvas needed. Canvas means the tarpaulin sheet. Okay. So area of the canvas needed. So which all areas we want to add?
CSA of cylinder shape.
CSA of cylinder
Shape.
cylinder plus
CSA of cone.
CSA of cone. So this is what we want to do: CSA of cylinder plus CSA of the cone. This is what we want to get. So we can write here. So CSA of cylinder. CSA of cylinder, what is the formula to find CSA of a cylinder?
2 pi RH.
2 pi RH. 2 pi RH. I told in the last lesson you want to memorize all the formulas. Curved surface area or lateral surface area means the area excluding the base areas. For a cylinder, there will be 2 bases. So you don't have to add the base areas in curved surface area. Curved surface area meaning total surface area minus 2 base area in the case of cylinder. In the case of cone, there will be only 1 base. So excluding the base area, the cone, the other face, that is only 1 curved face, only 2 face for a cone. Okay. Then plus curved surface area of cone, what is the formula?
Pi RL.
Pi RL. So we want to add these two. You can substitute the given values. So in this question, it is not given pi, but I think before the first question in this exercise question set, it is mentioned. If it is not mentioned, take 22/7. It is mentioned in the beginning. So that is common for all the questions. Okay, so we want to choose pi. I think after some simplification, we can substitute pi. Okay, so in the first step, no need to substitute pi. So 2 into pi into what is r? 2, right? 2 into what is h? H
2.1.
yes,
2.1
plus pi again, then r, radius of the cone. Radius of the cone is same. So we can write 2 itself. Then L. L is directly given. So that is
2.8.
2.8 meter. L means slant height of the cone. In some question, the slant height may not be given. Sometimes the total height of the tent may be given. Total height of the tent may be given, and slant height we have to find out in such questions. So suppose the total height is given. From that total height, if you subtract the height of this cylinder, you will get the height of the cone. From this right triangle, using Pythagoras theorem, then you can find out the slant height. We will do some question. We will see some question today. Okay. In the next step, something we can take outside the bracket. 2 pi is common. 2 pi can be taken outside. Okay, 2 pi is taken outside. 2 into 2.1 in the left side of plus. What will come? 4.2. And in right side of plus, what comes? 2 pi is taken outside the bracket. So that 2 is gone. So only 2.8 remains inside the bracket. Okay. So in the next step, add the numbers inside the bracket. What will come?
7.
7. Okay, 7 correct. So what is 2 pi? So now we can substitute the pi value. Then the 7 can be cancelled. So 2 into 22
44.
7 into 7. So 7 is cancelled. So we got 44. The unit? unit?
Centimeters.
Meter square.
Meter square.
Meter square. The lengths are given in meters or meter square. That's the area of the canvas needed, canvas used. Canvas is needed or used. So now we want to find the cost. Cost is equal to, given the rate of cost. Rate of cost is 500 per meter square. For each meter square, we want to pay 500 rupees. So for 44 meter square, what will be the total cost?
44 into 500.
Yes, 44 into 500. Can you multiply this? What will come? I think you can do in your mind.
So 20.
22,000 will come. 22,000 rupees will come. 5 into 44. 5 into 44 is 220. Then put 2 zeros. So 22,000 rupees will be the cost for buying the canvas. Okay. So I think this question is clear. A tent in this shape, a cylinder surmounted by a cone. Okay, conical top means a cone, and some measurements are given. I think all the measures are given directly. We don't have to find out by any subtraction or radius only we took by taking the half. Other measurements are given directly. Okay, this is very important. The first step, that is, you want to understand the question, then only you can write this step. The area of the canvas needed is curved surface area of the cylinder plus curved surface area of the cone. Okay, because we don't cover the base by canvas. Okay, so you may have seen such times in scouting, sometimes maybe scouting in school, or sometimes in a circus, you may have seen such tents. Okay.